What's up, everyone? I am back with another video, and it's actually not going to be a repair video, at least I hope not. So I figured I'd do something a little bit different for a piece of equipment that is a bit different, or something I haven't worked with before. It has a kind of cool, I don't know if history is the right word, but it's, yeah, let's just get right into it. So, this is a T-Rec Trek Model 610E high voltage power supply, amplifier, and controller. It can provide up to 10,000 volts at 2 milliamps, at a max of 2 milliamps. So it is by far the, I don't know if the most powerful supply, but it is the, I've never come across a supply that can get to this high voltage. And it's kind of cool because it's not just a supply, like I said, it's also an amplifier as well. And yeah, so why do I have this thing? Well, this is actually my company's. I was digging around for something completely unrelated in our storage closet, and I came across this, and I asked a colleague of mine who used to work with this if I could bring it into my space, and he said yeah. And so I thought it'd be really neat to take a look inside and maybe play around with it a bit, maybe hook the scope up to it. But yeah, so we had this grant for this application that's known as picodroplet generation, and it's a technique that is used to encapsulate a cell in a droplet that is basically on the order of picoliters, and that has a variety of different applications. That is beyond the scope of what I know. I am still not 100% sure why they needed a high voltage supply or an amplifier. This grant was kind of before my time, or it was just ending as I started here almost 5 years ago. So I remember seeing this whole thing set up, and it was very intimidating. There was a powerful microscope set up with it, all these wires, and it wasn't readily apparent that this guy was visible, this supply, or at least I didn't notice it at the time. But yeah, it was just a unique setup, and yeah, I mean, I was still very green at the time, so I just kept my distance. But yeah, I don't know. But anyway, that is what we used to use this for, and it has sat in storage for a very long time until I found it just now. But yeah, so it's got this 3-digit display, and you can see here it's got these two settings. One for 0 to 1 kilovolt, one to 0 to 10 kilovolt. You've got your choice for the meter, at least you can read in volts and amps. This controller here is to set your voltage or your current. You can change the polarity here with that switch. And this is basically a limiting switch, current or voltage depending on what setting you're in. And then of course you have the function switch here, and then the high voltage switch to turn that on. You can also turn it on remotely as well. And then in the back, let's see if I can, this is where you connect. You've got your high voltage connection there. You've got that green binding post there is your ground. And then you've got a couple connections for current and a few other connections here. This is for the input so that you can use it for as an amplifier. All right, so yeah, and then this switch is part of the apparatus for the picodroplet generation. They literally had a light switch here. This is for the high voltage supply. I don't know what voltage they required. I hope they weren't using volts in the 1,000 range for this, because it certainly isn't rated for that. But yeah, I'm telling you, this apparatus was quite impressive that they had set up, and I wish I had taken a picture of it when it was all together. But yeah, so anyway, I figured we'd take a look inside first, see what's going on there, and then play around with it for a bit. Wow. Look at everything going on in here. This is so cool. Very cool. Wow. Well, let's see. I'm not sure I know what all this stuff is, but let's just kind of take it from the input, AC input back here. So you can actually see that it looks like that's where it would connect. That's exactly where the input is, and then you've got all this wiring coming off. Might be an X cap there or MOB, I'm not sure. That red thing there, and then all this cabling kind of goes behind this, which we'll get to. You've got this fan here, and here's the wiring again coming through here, comes to the mains power switch on the front, and I think it then goes to this transformer, which has, it's a multi-tap transformer. You've got this red wiring coming to this board here, and also going to this board, which it looks like to be the main power supply board. Okay, so you've got this tap here, which comes off the top. I don't know if this is just also mains, you know, like 120 volts. I'd be curious to measure it. And this just looks like I don't know, it could be a switch mode power supply. You got the PWM there, that's a UN 3846, yeah, so that's your PWM, that's an optocoupler right there. There's your bridge rectifier right there. Let me just flip this thing around. Alright, so I got this thing turned around here, and I'm really running out of space because I've got this cart full of stuff that I still need to finish, but won't get into that. Anyway, you know, just taking a step back for a second, I mean, this thing looks really well made. I mean, look at the point-to-point wiring on the front panel controls. Definitely using quality components. Yeah, I mean, there's a lot of shielding, all the wiring bundled nicely. It's just really planned out nice, just crafted really well. But anyway, looking at the main power supply here, and it looks like it's a switch mode power supply. Looks like it's a boost converter. You've got this guy right here. This is an LM2577, which is a step up voltage regulator, but can also be used as a flyback regulator. It's an LM317, which could be supplying voltage to this UN3846, that PWM, and you got these two power MOSFETs here, and then a transformer which is stepping up the voltage. And I mean, you can tell, look at this thick wiring here, and it looks like it's going, this is just completely shielded, so there's no discernible part number on it or any identifying lettering on it, but it looks like it's a high voltage multiplier, so that could be further increasing that high voltage coming from this boost converter. And then you've got these tubes here, right? These look like high voltage shunt regulator vacuum tubes, and there is a part number on them, but I'll just pull up the data sheet for you guys. I think I have that up. Yeah. So here they are. Look at this. The 6BK4C, or also known as the 6EL4A, shunt voltage regulator. Color television type. Look at this. Wow. Unregulated supply, 36,000 volts. Plate voltage, 27,000 volts. Wow. Maximum X-ray radiation. Wow. Okay. So we won't be powering this up with the panel off, or at least turning on the high voltage. We got a nice reference circuit here. Very cool. Yeah, so that's what those tubes are. They are regulating the high voltage. So cool. Very cool. And they're actually marked positive and negative because you can switch. Well, we're looking at the backside, but you can switch the polarity of the voltage. So that's really neat. And then you've got this tube here that is also shielded. I am not quite sure what that is. Now, it has screws on the top and the bottom, or the sides, and you've also got wiring coming off of this side, which looks like it's at a much lower voltage. It's connecting to this board, obviously, so it has to be. I'm thinking it could be some sort of current monitoring. I don't know. I'm not quite sure. Be curious maybe to open that thing up, take a look inside, but that's what I'm gonna guess. Of course, if anybody else knows, please put it in the comments, but not quite sure what that is. Okay. And then, yes, this feeds out to your high voltage output. Yeah, just really cool. Really, really neat. And then you've got this board here, which is probably doing more of the digital, you know, the controls. Let's see what we've got here. The amplification as well, I'm assuming. Yeah. It's just really, really neat. Really neat. Oh yeah, and then under here, yeah, I thought these at first were transformers. It might be kind of hard to see, but I believe those are just big chokes. There's only two wires coming out of each of them, and they connect to these two regulator modules. So yeah, I think those are just big chokes. And yeah, I think that's about everything. Well, that's really neat. All right, well, I think now that we've kind of had a look inside, let's maybe mess around with this thing for a bit, see what it can do. Okay, so I was really curious what that transformer was putting out to the power supply board, and it's about 32 volts AC. That's just, I'm just getting poor connection there, but yeah. Okay, and I was just dying to know what that boost converter is putting out, and it's a roughly around 400 volts AC. Um, it's center tap, so you got 400 volts, and then 400 volts, 800 volts across both windings. So yeah, pretty cool. I did check it with my high voltage probe first because I really wasn't sure what was coming out of that um, supply. So I did check it with that first, and then it was clearly under 1,000 volts or what my meter could handle. So I decided to hook it up with the regular test leads, but pretty neat. So I just wasn't satisfied with that reading from my multimeter. I had to break out the scope to probe it, and so I've got one of my high voltage differential probes out. This is the Mixig 20 DP 20003, so it has an attenuation factor up to 2,000, so you can probe some pretty high voltages safely. Yeah, because I think I had said that was AC voltage straight from the transformer. But the only problem with that is, well, how is this AC voltage getting rectified? You know, the tubes, the regulator tubes, they take DC voltage. So, you know, I just wanted to just check what the waveform was on that output, and so got this hooked up to the Tech TDS 754D, and this is the waveform. So it looks like it's a square wave, and I think that ringing is just due to you know, a mismatch of impedance. I don't think that's the actual waveform. I mean, I could be wrong, but we got a frequency of 24 kilohertz, and then a peak to peak of 800 volts. And so it's a square wave, so that's why we were seeing roughly 400 volts on the meter. But yeah, that's pretty neat. Alright, so we got it all back together. Got it in power supply mode. I figured we'd play around with it in that first, and right now it's at the 0 to 1 kilovolt range. It's at roughly 300 volts, showing 297 volts on the display, and it's very accurate through 97 right there. Let's just see. How high it'll go. I mean, we know how high it'll go, but still very accurate. I think it had a calibration sticker on the back from like 2013 or something. Yeah, I mean, I wouldn't be surprised that it wouldn't be able to go all the way up to 1,000. That's really pushing the limit of this meter. It's only rated for 1,000 volts. But yeah. All right. Let's check the higher range. All right, so we've got it set to the 0 to 10 kilovolt range. Got my high voltage differential probe. I got rid of that switch because it's a little bit it's a little sketchy. Definitely for voltages over 1,000 volts for sure. But yeah, I can't reach, but that's pretty much what that's very accurate. Awesome. Very cool. Let's just crank it up all the way, why not? Alright, that's as high as it'll go. Let's take a look. There you have it. Yeah, and so by the way, you know, this is the high voltage probe. It has a series of resistors in there, which steps the voltage down 1,000 to 1. All right, so you're, instead of 10 kilovolts on the meter, you're seeing 10 volts. Alright, so that's kind of how that works, so you can safely measure high voltages. So you're not measuring that voltage directly, but yeah, very cool. I would like to try and test out the amplifier as well. Alright, so the amplifier portion of the unit works like this. You can apply an external signal, and using those same settings, the 0 to 1,000 volt or 0 to 10,000 kilovolt, these are your options for amplification. So it can amplify at 100 volts per volt or 1,000 volts per volt, which is pretty awesome. So I was thinking of maybe applying some sort of signal with one of the function generators or pulse generators, and using the high voltage differential probe again to check out the waveform from the amplifier. Alright, so we're gonna test the amplifier. I had to take the panel off, the top panel off, because the amplifier input is this 3-pronged input. I don't have anything like that to hook up to, so I just am connecting straight to the board right there. And I am using this HP 8116A pulse generator. I've got the amplitude set to 10 millivolts. I thought it'd be cool to try to amplify a much lower voltage. And let's see, we're at a frequency of just 1 kilohertz. And yeah, we're triangle wave. And so we should be getting, amplitude is 10 millivolts. We are at the 100 volt per volt amplification setting. Okay, so we should be getting 1 volt peak to peak, and we aren't and it's a little bit noisy, but again, I am running it through this super long cable. There's no shielding as well. The amplitude input has a shielding connector. I don't know, it could be a number of things that's causing that. Let's just, hold on. Okay, so that's actually the baseline. So that could explain that. I don't know why that is doing that, but could be for any number of the reasons. Yep. Yeah, I don't know what that's about. I wonder what happens if you switch it to the higher amplification setting. Oh, it gets crazier. That's interesting. Alright. Well, let's try that now. Let's see what happens. Let's turn on the pulse generator. Oh boy, what's going on here? Okay. Oh, that actually looks nice. Oh, okay, that's right. My bad. So amplitude, I see. I think that it's not peak to peak amplitude. It's just, yeah. So it is. It's doing pretty well actually. Again, this is a 10 millivolt amp, 20 millivolts peak to peak on this triangle wave coming from the pulse generator, and it's giving us a 20 volt peak to peak, and it looks relatively clean too. Yeah, that looks great. That's awesome. So it works. It's pretty cool in both settings. So yeah, that's pretty awesome. That's actually the lowest output you can do on the 8116A is 10 millivolts, so can't go any lower. But I think that's really cool. Now apparently you can add an offset to it by, jeez, I am really running out of space here. So if we well, you know what? I don't want to overdo anything. Let's just do 10. And just see. Where did that go? Holy crap. Hold on. Okay. So if I bring it up to 10, that adds a 10 volt offset. See, I had it at the 100 kilovolt setting, or the 1000 volt per volt amplifier setting. That adds 100 volts. So glad we switched that. But yeah. I'm sorry. Very cool indeed. Yep. Okay. Okay, well, I hope you guys found this interesting, really neat piece of equipment. Awesome to look at. Uh, you know, yeah. I don't really do teardowns that often. One, because look, I learn from repair, okay? So I can't speak in detail the way some other guys can on how this stuff works. And so that's why I love repairs, because I learn each time. Not that you can't learn from this, but it's just more fun for me, and it's a learning tool as well. But this was fun. I really enjoyed doing this. I hope you guys enjoyed watching. If you have any comments, feedback, leave it in the comments. If you know what any of these components are that I missed, please let me know. But yeah, I'll catch you guys at the next repair or teardown. All right.